Hi, welcome back to another episode of Real World Serverless, a podcast where I speak with real world practitioners and get their stories from the trenches. Today, I'm honored to be joined by Dale Salter from A Cloud Guru. Hey, welcome to the show.
Thanks, Jan. Thanks for having me on. I'm super excited to be here.
So, you've been with A Cloud Guru pretty much from the start and have gone through the whole journey of growing with the company. Can you tell us about yourself and A Cloud Guru for those listening who are not familiar with who they are?
Yeah, so my name's Dale Salter, and I've been a serverless developer now for the past 4 years at A Guru. I joined very early on in the startup phase. I was the second developer, and previously to that, I worked at a software consultancy company that focused on .NET. So ACG or A Guru is a completely serverless cloud training platform with a strong focus on keeping our learning really fun and engaging, and we've taught over 1 million students on how to pass their AWS exams, GCP exams, and Azure exams. And we have a lot of content related to serverless. But not only do we teach serverless, our entire platform and ethos is all around serverless computing and has been that way since we've started. So we try to practice what we preach by really following a lot of the stuff that we teach in our content when we build the platform. And just to be specific, that the team that I work on and a part of what I do is actually building out that serverless cloud training school. So it's been really, really exciting to started from when we're really tiny to where we are now. And just to put it in perspective, this is like not a really small serverless app. We're quite large. To put it in perspective, we have roughly 240 million Lambda calls per month. So that's like about 100 Lambda invocations per second, 180 million API gateway calls a month, which is about 70 per second. And we're moving roughly 90 terabytes of data through CloudFront, which is around 300 megabytes a second of video content out to our students. So this is definitely not a small serverless application by any means.
So, A Cloud Guru was serverless, fully serverless from day one. Do you know what was the reason for the guys to choose to go serverless from those early days when the whole technology space for serverless was still quite immature?
Yeah, so really serverless was a need or came out of a necessity essentially. So Sam, our founder, had a very small amount of time. He took around 3 weeks off the job that he was working at the time to essentially build out this cloud school. And he had only a tiny amount of time to do that. So he took his family down to Tasmania, which is a small state within Australia, and then he focused on trying to build a school or a product within that small amount of time. And if he were to have used traditional approaches like the serverful approaches, he wouldn't have been able to do it in the time that he had done it. At the time, we weren't interested in building like an amazing technology architecture or paving the way on something new and exciting. It really came. The serverless approach really came out of a need of necessity, right? To build something very, very quickly in a tiny amount of time. So A Guru really has been serverless from day dot. Within A Guru, we've never used any ECS or EC2 or any of those the server full technologies. We've really focused on using and leveraging DynamoDB, Lambda, API Gateway, CloudWatch, SNS, and so forth. So one of the reasons why we knew we needed to build a serverless platform was that we had a whole bunch of users on another platform that we needed to move across essentially, or to help encourage to move on to A Guru. So we didn't want to have to worry about the things to do with auto scaling or provisioning or managing servers or outages that happen in the middle of the night. We just essentially wanted to have a product that would just work and scale elastically with the amount of users that had come on. So one of the interesting things about A Guru is that initially we started with a Firebase database. So for those that don't know, Firebase is essentially like a big JSON file in the cloud that essentially has like WebSockets to be able to talk to it back and forth to pull data. And the way that you talk to Firebase is essentially directly from a client, so like a SPA or something like that, to the database directly, and you manage security of that database through a JSON policy. So what having this allowed us to do was it essentially allowed us to not have to build out a backend at all. So in a traditional application architecture, you'd have a front end, an API layer, and a data persistence layer. We could actually cut out a lot of that middle work that would be involved in the data persistence and just have that directly in the client. So that was like a completely serverless database, and it was also essentially a backendless system at the time. So one of the interesting things here is that that worked for a lot of the different various parts of the early A-Cloud Guru system, except for one key piece, which was payments processing. So we needed to basically have a way, or a secure, authenticated execution environment, to be able to, when a payment had come in through something like Stripe, to be able to process it securely and write into the database that, hey, like this person actually did purchase this course. And at the time, serverless was really in its infancy, and functions as a service was as well. So we actually looked to Auth0, and Auth0 had this thing, I think it was like called WebTask or something like that, which we essentially used for that processing. We also had all our videos on CloudFront and S3, and the transcoding pipeline through that as well that managed all the transcoding of all of the videos on A-Cloud Guru. And at that time that we were actually writing this thing into WebTask on Auth0, AWS had just announced Lambda. So this is back in 2015. So we had our Firebase backend, we had a couple of Lambda functions, and a really thick Angular 1x front end. And this was really awesome. Like, we didn't have to deal with all these like API layers or anything like that, and was something that was like completely managed in AWS. So we really had this mantra of buy over build, where we would essentially leverage as many services as we possibly could with functions as a service for compute on our backend, to really put this school together. And we essentially wanted to avoid all of the undifferentiated heavy lifting associated to having to maintain cloud servers and infrastructure and all of that sort of stuff. So the story was a success, and A-Cloud Guru did launch with a completely serverless school. And that wouldn't have been possible with a serverful model, because all of these other things that would have taken potentially 3 weeks by themselves to implement authentication or an API or auto-scaling or anything like that.
That's exactly the kind of startup story that I like to hear. It really breaks my heart when I hear the loads of startups going down the Kubernetes route and spending 6 to 12 months just getting some MVP out, when you can do what you guys have done and just get something out and working in a couple of weeks and then go from there. Since then, I guess you guys are now a much bigger company. You have acquired the Linux Academy. So how has that, I guess, transition over the last couple of years? How has that been? What were maybe some of the pain points? Was there anything that you guys have to do very differently compared to what you were in terms of how you organize yourselves, how you manage your code? And maybe we can talk about how your architecture has evolved over time as well.
Yeah, awesome. So I want to preface this with, I think the biggest challenge that we had throughout this entire process was latency. So serverless systems tend to be quite a lot slower, potentially, especially if you're not careful, than perhaps their serverful counterparts. So a lot of the architectural decisions we had made, we really kept performance and latency in mind. So based on what I was talking about before, we had a Firebase database, we had an Angular 1x application, and a couple of serverless functions. And as we started building out the developers, so I think at the time we had this kind of architecture, there was only about 3 of us or 4 of us. And we knew that this was not going to scale up in terms of developers working on it, right? So this system was completely elastic and scalable from the amount of users that we could have, but it was not going to scale out with the development team. At this time as well, we were starting to think about building out a mobile application, and we knew some of the shortcomings of this initial architecture or this initial MVP was that our front end was a thick client and had all the data access logic and all the services within an Angular application, and there was no way we were going to be able to reasonably share that with a mobile application. Also, the other shortcomings of Firebase was that it had no transaction support. It wasn't running in a all of the data access logic was running in the front end, which is not a reliable or consistent compute environment. So if you had network issues or something like that, it could potentially mean that the write that you were performing to the database wasn't completed. So at this time, we decided that we'd actually start investing in building out serverless microservices. And initially, we first started with HTTP. So this was a very traditional thing that we had used during other companies that we had worked at, and we were very comfortable with using REST. And that worked really well initially, but considering we were starting to build out an API and GraphQL at the time was getting a lot of attention, we thought, hey, like GraphQL is almost like a superset of the functionality of what REST gives us, but we actually get a lot of the fancy things like types, and you get this idea of an application data graph and all of these other awesome things that you don't get with REST. And also, it works really, really well with mobile applications because you only have to fetch the data that you need and what the client's specifically looking for. So as we evolved the API over time, we weren't returning to additional properties to the mobile application that they didn't need. So we actually transitioned from our old thick client with a database that was accessing it directly into a microservices model. And the way we did this was we used what's called a strangle pattern. So essentially what that meant was every time we used or built new functionality, we asked the question, would we implement it within the old way, which was that thick front end and the Firebase database, or would we write it completely new in a microservice? So that was the way that we slowly transitioned it over. And at the time, AppSync wasn't a thing yet. This is back in 2016. So we're actually running, and we still do this today, we're running GraphQL.js on the Lambda function itself. And, API Gateway fronts that, but all of the business logic is being run within a Lambda function using the GraphQL.js library. So at this time, we knew that we had all these different microservices, which was great, but GraphQL actually requires or encourages you to have all of your data accessible from a single endpoint. So the idea is that all your clients only know one URL that has your whole API on it. But we knew we also wanted microservices which were bounded contexts, right? So we wanted to have a service that was specific for checkout and a specific service for course and student course taking experience, and one for web series and transcoding and stuff like that. So the way we accomplished that was through what we lovingly call our backend for front end, or our BFF. And the way this architecture had worked was that the BFF had GraphQL.js in it, and the resolvers would call into Lambda functions that each microservice owned. So the interface to a microservice was a specific Lambda function name. And then when you called into BFF, BFF would run GraphQL.js, and then it would delegate getting the data down to the microservices that owned that data. This model worked fairly well for quite some time, but one of the things that we ran into when we did this was that it was essentially really slow, because at the time, if you needed for a given query to hit 4 Lambda functions, and sometimes they were serial, you could potentially run into 4 cold starts on your worst case. So your P99s were really, really bad with this model. In the case that you do hit those cold starts and you hit 4 of them at once, which could happen in some scenarios. And we also knew that every time we had to extend the API or build in new functionality, we had 2 services we had to touch. So we had BFF, and then we had to touch the downstream microservice, which had that functionality. And that was essentially slowing us down, right? The lead time to be able to make a change and deliver functionality to our customers became slower due to this architecture and not faster. So what we ended up doing is we ended up making, keeping in mind performance and being able to deliver really quickly. What we did was we had microservices now expose their own GraphQL endpoints, right? And then all BFF did was it just stitched all our microservices together so it could still serve up all of the application APIs to the front ends. So it would actually stitch them all together at runtime and then be able to, for certain parts of the query, delegate those down to the microservices which were responsible for those. So we moved from this model of essentially having one microservice having lots of Lambda functions which could have cold starts to each microservice being one Lambda function. And this really improved our performance because, at most you would essentially only pay 2 cold starts. And it was very unlikely you had to pay 2 because all the BFF Lambda functions were always quite hot. So this is essentially how we addressed both the slowness and then also being able to deliver really quickly. And then sometime after that as well, we introduced async messaging with SNS and SQS, but I'll talk about that later.
Thank you. That was a really detailed walkthrough, and I loved a lot of details that you put in there. I think there's a lot of things for us to drill into here. For example, the schema stitching and runtime you talked about. You said using some of these experimental spec in the GraphQL space. I think the latest one is now what is called the schema federation.
Yep, that's correct. Yep. So what we essentially did was we even went one step further here in that the BFF doesn't actually have knowledge of the downstream services. We created our own federation service essentially. And what it would do is each time a request came in, it would first call out to our federation service. It would get all of the information for the microservices that BFF was responsible for or could be able to delegate it to. It would introspect the data that came back and then know which service it could delegate portions of parts of that query to through that federation that you're talking about. So we essentially even went one step further in that every time we added a new microservice, we didn't have to change our BFF. We just registered ourselves to that federation service.
Okay, gotcha. In this case, is AppSync something that you would consider in the future? I guess not for the BFF, but for the microservices, because I guess that means potentially a lot of the time you can call out that one Lambda invocation that you have in the microservice, because probably AppSync can do the job for you and go straight to DynamoDB or whatever support to the data source that it has.
Yeah, so the great part about this architecture is AppSync is a GraphQL compliant API service, right? So if it were to be something that we wanted to use or experiment with, we could very well stick it behind our BFF and it should just transparently work. So we could have these microservices that still using GraphQL.js and then some of the services that are using AppSync. At the moment, we haven't gone as far as to look into AppSync too much. This may have changed since we've last looked into it, but I think some of the issues that me personally I understand with AppSync can be that you have these like DSL files and you potentially relinquish some of that control that you may have if you're running GraphQL.js within Lambda entirely. But what I do think AppSync potentially could be really good for us for is that rapid prototyping of a new microservice or a new backend or something like that to prove a proof of concept, because you don't need to write a lot of that glue code. A lot of those integrations directly hook into, like you were saying, they hook into DynamoDB, or you can write a Lambda resolver, or they can hook into things like serverless Aurora and stuff like that. So it's definitely something that we're still gonna look into.
Yeah, I've been working with AppSync on quite a few different client projects now, and I have to say the developer experience there is great. It's really, really quick to get something running. I've got some reservations around Amplify CLI at the moment. I think it takes too much decisions that I don't always agree with, but I think just working with AppSync itself has been a really good experience, at least for me. Another question I've got around, I guess, your use of GraphQL is how do you handle some of the sort of common challenges with GraphQL, things like overfetching or underfetching?
Yeah, um, so overfetching or underfetching. So I guess um, what we essentially do here is to avoid this idea of overfetching is that you implement dynamic resolvers within GraphQL to only fetch the data that you need. So in theory, you shouldn't need to overfetch more than what you need within GraphQL because each entity maps to a resolver, and usually you're going to load the whole entity and then only return a projection of that entity to the client. So you're not returning some big graph of data and then only mapping to a tiny subset of it. You should only be fetching the entities that you actually need to resolve an individual request.
Yeah, I guess if you're careful and when you're building your BFF, but also the model, but also when you are building the client. But one of the things that's always, I guess, I worry about in the back of my head is that, well, if an attacker is looking to launch some attack against my system, the fact that they can hit a lot of different resolvers from a single entry point, asking for one piece of data and then asking for related data by traversing the data graph, they can increase the magnitude of the attack by hitting me with some overfetching queries. Is that something that you guys ever thought about or worry about?
Yeah, so we know that GitHub does a lot of stuff here due to the way that they work, at least from what I understand, is that they attach a complexity metric to each of the resolvers within GraphQL, and they have a certain level of nesting that you can actually resolve to. So whilst we haven't found the need to have to do that within aCloud Guru just yet, there's definitely ways that we could implement that if we do need those sorts of things. I guess one of the nice parts of a serverless system is that it should, in theory, be completely elastic. So if we do get attacked, a lot of the system should be able to dynamically scale up and down to be able to deal with that. But at the same time, it would be more desirable to be able to prevent that query from even executing at all. That's definitely something that we'll need to look into.
Yeah, that's why I guess in the serverless world, we are now calling denial service attacks denial wallet attack because you can force your way through it, but it's going to cost you a lot.
Yeah, funnily enough, within serverless, I one day introduced this bug within our video player that essentially caused each of our students to continually hit a serverless GraphQL backend, and it would do that essentially like every second. And we had, a few hundred students watching that video at the same time, and we ended up DDoSing ourselves. But one of the cool parts of it is it actually made the application faster rather than slower because of that DDoS. It wasn't sustainable because we're essentially calling our backend far more than we should have. But it's quite a funny side effect of a serverless system is that it gets quicker instead of slower.
That's funny because of the whole warm cold start. Now you're kind of eliminating it by DDoSing yourself. And it's funny you mentioned that as well, that Ant Stanley actually did the same thing. We launched an online workshop, it was in May, and he built a front end and he had a bug where he was making a request to the backend constantly as well every couple of seconds. But yeah, everything was working fine. The system just scaled automatically. But then when he looked at the bill, he said, "Oh, okay, what's going on there?" it wasn't huge, but still, it was something that was noticeable, a big spike.
Yeah, that's right. Hopefully, it's something that your CloudWatch metrics should be able to pick up and let you know about.
Okay, so final question, I guess, around the whole GraphQL side of things is, are you guys using GraphQL subscriptions at the moment?
So that was definitely one of the things that we haven't been able to do, is that GraphQL subscription. Essentially because when we first looked into our GraphQL implementation, API Gateway didn't actually support WebSockets. And you need some way to be able to do some kind of pub-sub model to be able to implement GraphQL subscriptions. Because GraphQL subscriptions are only a specification, they don't actually talk about the implementation of those. So this is really where AppSync would have been really, really nice for us to use, because you get those subscriptions through AppSync. At the moment, we haven't really reinvestigated implementing subscriptions now with API Gateway WebSockets, because we haven't had a piece of functionality that would really need them. But it's certainly something that's would be really, really nice to be able to do, is having that, having people be able to subscribe to GraphQL queries and then having the UI dynamically update once the underlying data store's changed. So something that's really, really exciting for us, that when the right opportunity comes up, I'm super keen to be able to get onto it and use it.
Yeah, something like that would be really easy to do with AppSync, but probably quite hard to do with API Gateway, just because of the way API Gateway implements its WebSockets. It's a very low-level construct. You have to keep track of the connection ID and all of that yourself, and do the mapping of who's subscribed to what content. But certainly, I think with AppSync, the whole subscription thing has been really easy, and I guess it kind of brings back some of the power you had when you were running on the Firebase as well. That the client can subscribe to changes in the database and be notified easily when something has updated.
Yeah, that's correct, and that's something that when we were moving away from Firebase, we ended up giving up a lot of those the subscriptions that we had. And there was a lot of things that Firebase managed for us under the hood that we now had to manage ourselves, going into an API sort of model that Firebase and Firebase's SDK would deal with for us. So those are things like pipelining and caching and concurrency and all of that sort of stuff.
I want to take a moment to give a shout out to this week's sponsor, Chaos Search. Chaos Search is the fully managed log analytics platform that uses your Amazon S3 storage as the data store. Companies like Armor, HubSpot, AlertLogic, and many more are already using Chaos Search as a critical part of their infrastructure and processing terabytes of log data every day. Because Chaos Search uses your Amazon S3 storage, there is no moving data around, no data retention limits, and you can save up to 80% versus other methods of log analysis. So if you're sick and tired of your elk stack falling over or having your data retention squeezed by increasing costs, then visit chaossearch.io today and join the log analysis revolution. Okay, and let's switch gear a little bit and talk about some of the microservices and how you organize them into repos and CloudFormation stack, and basically how you manage the whole sort of development and release cycles for those microservices. Since now you've got quite a lot of different engineers working on them, so I imagine you have to think about how many engineers are touching the same code base at the same time and all that stuff as you scale the team.
Yeah, so in the very early days, we essentially didn't have this idea of teams. It was just individual developers all just chaotically working on features. And as we've grown out, we've expanded from that model of having, essentially like single person teams into having teams that are responsible for specific domains. Those are cross-functional teams. That each team has a PM, a designer, a lead, and then 3 developers. And those teams are responsible for individual domains. So one team might be responsible for things like our students, another might be for organizations, courses, mobile, and all of those things. Now, for each of those teams, they actually work out of the same repository. So we, at A-Cloud Guru, we use a mono repo. And the way that works is we use a service called BuildKite, that every time a change happens in that repo, we run a little detection script to look at what has changed in a folder and then figure out if we need to do a redeployment based on that change within that folder. So that folder you can kind of think of as a project. So you've got your mono repo, and your mono repo has lots of front end and back end projects. And then based on those changes, it'll only deploy the microservice where that change has existed. So we use trunk-based development for that. Every time a change happens and it gets merged into master, we then push it into our testing environment, and then we do push button deploys into production from there. Only after the linters run and the automated tests and so forth.
So in this case, does Buildkite, so are the sort of detection script, is that part of what the Buildkite does for you, or is it something that you guys have to do yourself? And does it detect changes that are made to shared code? So maybe not to the folder where the project is, it is, but it makes some changes to some shared code which would impact one of the microservices.
Yeah, so we've Buildkite's very extensible, and we ended up writing a plugin to be able to add monorepo support into Buildkite. And the answer regarding those shared packages or shared code is we don't share anything across microservices or any code across each of the folders. The only way that we manage shared code is through NPM packages, and we have a specific repository that uses Lerna that has that shared code in it. So each of the dependencies are all versioned and packaged together. And, if we bump a package, it would change a package.json or a yarn lock or something like that, and then cause a redeployment of that microservice. So we don't have this weird problem where we change code in one place and it has to trigger a fan out of microservice deployments. So each of the deployments are, consistent, versioned, deterministic, and so forth.
That's actually very interesting, because for a lot of people that I spoke with that are doing monorepos, one of the motivations for going monorepo is to make share code easier, so that you can have one PR, one commit, and that will update the share code, but also all the services that depend on that share code, without having to have that separate sort of flow whereby you update the share code, you publish a new version of that library, and then you have to then go back to the services and then update each service to a new version. So what's the reason that you guys have decided to go against that approach of managing share code? Is that because you want the teams to own the update cycle for when their service is going to adopt this new shared code?
Yeah, that's correct. So when you make, one of the things about shared code is really risky if you change it, right? And it's really hard to understand the impacts of what bugs it may introduce. So if you update a piece of shared code and then have it propagate across 10 different microservices, if you don't understand each of the microservice that uses that shared code, you don't understand potentially if you've broken something for someone else, right? So having it versioned and packaged means that teams can opt into it when they're ready to be able to upgrade a piece of shared code or something like that, rather than you doing it yourself and not understanding the impact. So that's predominantly the reason still why we use that package style system of like versioning of libraries and NPM modules and repos. But the advantage of still having that mono repo is that you can still very easily see across the entire application what changes have been made by each developer. And you don't have to now wonder within your GitHub organization, what microservices are being deployed to production. You can just look at one place and it has the entire state of the world all in one repository for your entire organization, rather than having them scattered across the organization in different repositories.
Okay, yep, that makes sense. And what about in terms of the communication between different microservices? I think you mentioned the SNS and SQS before. Is that basically how you are communicating between different microservices?
Yeah, so for synchronous flows, for synchronous flows between microservices, we use GraphQL to be able to manage those communications. And the advantages of using GraphQL is that you have a typed interface that that you can use to communicate between those services. And one of the cool things about GraphQL is there's a lot of really cool things that you can do when the consumer connects to the producer or the server and requests a set of data. It helps with being able to deprecate those requests because you know what individual fields are being fetched by the consumer. And the reason and the way that works is the consumer has to identify itself as I am X service and I'm requesting Y data. And then when you go to change that data on the server, or in this case on a Lambda function that's running GraphQL.js, you know what is being consumed by you and which microservices are depending on you. So you could, in theory, build like a graph from that. So our request response is done through GraphQL. Now we've also started moving towards, and this is something out of performance as well, is moving to SNS and SQS. So microservices can, in theory, subscribe to data from other microservices. They could cache that data, they could transform it, anything like that. Within a DynamoDB table, they can keep that cache or that transformed data. And then anytime that a service changes the data that is dependent or is being cached, it can push a notification to say, hey, your data is no longer valid, or here's your new data, store it. And one of the advantages to this is because making a service-to-service call can be 150, 200 milliseconds, whereas if you're just pulling that data directly within your own service in a DynamoDB table, you've got single-digit latency. So it definitely improves that performance. And then other advantages to using that SNS, SQS model is that you get improved resiliency. So if your service goes down for whatever reason, you can still service requests from your data store that you're keeping locally.
Okay. I guess I've got an interesting question there is that with something like AppSync, you can say for different queries, operations, or mutations, you can have different authentication models so that for the same GraphQL schema, you can have some operations that are dedicated to an inter-service calls that is expected to come from another GraphQL, another microservice. But some of them are coming from the user, so it's authenticated by Cognito, for example. So in this case, you've got microservices that are potentially being accessed through the BFF, and then there's also other operations that are accessed by other microservices directly. Do you have to make some distinction in terms of the authentication model there, and or do you have to replicate basically what AppSync does?
Yeah, so we have to replicate what AppSync does. So the way that the front end talks to the back end is through Auth0 and a client-side JWT, and that hooks into BFF. Once you're within the BFF environment, you're within a secure area, and the way that services talk to each other is using JWT that comes from Cognito. So service-to-service calls are authenticated with the JWT that's coming from a Cognito pool. The way that we manage the different types of resolvers and the way that they're called and whether they're coming from front end or they're a back end to back end call or something like that is that we use GraphQL directives to basically say who can access this. Can it be a viewer, which is a front end? Is it a server, which basically just says, is it a server-to-server call, or is it like a role within the system? So we have internal roles at A Cloud Guru that, might be an editor or an instructor or something like that. So we've implemented our own way of managing that problem that's not using AppSync.
Okay, got it. Yeah, AppSync doesn't make that very easy as well. And especially when you're using Cognito's groups, which is something that I've really struggled to implement to replicate with API Gateway, because you kind of end up have to write custom Lambda authorizer and all of that stuff as well. AppSync just make that a lot easier.
Yeah, that's right.
Yeah, and I guess the final thing I want to get from you is what about your top 3 AWS wish list items? Are there anything that you really love to see AWS improve in this serverless space?
Yeah, absolutely. So the 3 items that I'd like to see the serverless teams implement would be within Lambda functions. At the moment, Lambdas don't have this idea of being able to run a backend job and be able to respond to API Gateway at the same time. So what I mean by that is, so say you have a bunch of analytics or telemetry. Those analytics or telemetry, you have 2 options. One is that you can wait for those calls to come back when you're firing async jobs before you respond to API Gateway. Or you can respond to API Gateway immediately, and then those pieces of telemetry will get sent in your next Lambda invocation to that same container. So the tricky part there is you can get that performance of being able to immediately respond as fast as you can in request response, but you could potentially lose pieces of telemetry if that container doesn't get spun up again. So what would be really nice is Lambda to be able to respond to the browser or to whoever's calling you, but also still be able to have those pieces of telemetry still get sent off after your callback or your promise in your handler is finished.
Yeah, that lack of background processing has been a pain in the butt for all the different vendors. I do a lot of work with Lumigo, and all the other different vendors have the same problem as well, that to collect telemetry and traces about your application, it can end up eating into your invocation time because there's just no background processing. But I think something may be coming in the future to address this, because it's something that's been asked for for very, very long time now. Or the fact that you can only have one subscription filter for CloudWatch logs, which is also a big pain point. So Dale, thank you so much for joining me today and for sharing your experience and your journey with CloudGuru. It's been really insightful, and I'd love to hear some more of what you guys are doing in the future.
Yeah, thank you very much for having me on. It was a lot of fun.
So final thing before we go, how can people find you on the internet, and do you have any sort of personal project that you want to tell us about?
So if you want to find me on the internet, I'm on Twitter. My handle is Enepture, Enepture, or you can find me on LinkedIn at Dale Salter. And is there any project that I'm working on? Currently, I'm just tinkering with Serverless Aurora, just playing around with that, seeing how RDS works with a serverless model. So nothing there too interesting just yet, but I'll be sure to share it around once I've finished tinkering.
Excellent. Looking forward to reading that blog post.
Thank you.
Okay, man. Take it easy. And again, thank you so much for joining us today, and stay safe.
All right. Thank you. See ya.
That's it for another episode of Real World Serverless. To access the show notes and the transcript, please go to realworldserverless.com. And I'll see you guys next time.